So this video will focus on Chapter 5, Section 3. And the very first thing it says is to write two equivalent ratios for the ratio given. So I have to look here and I have 10/15ths. So something that is equivalent to 10/15ths. I could reduce it and get take a 5 out of each, so I'd have 2/3. Or I could actually double it if I'd like to. I could say if I have 10/15ths and I multiply the top by 3 and the bottom by 3, I could have 30/45. So what I'd like you to do now is pause the video and try to find equivalent ratios for each of these. Alright, so now that you've had a chance to do this, let's see what you have. So here's one example, 2/3. You could also double 2/3 and get 4/6. Of course, 30/45 would work too. This one here are two equivalent ratios. Here's another. And of course, there are countless others, but these are some examples to see if you're on the right track. And basically, we want to see how you can write a proportion that solves a problem in real life. Because let's face it, all the math that we learn in this class, I want you to be able to actually see where it's applicable in real life situations. So here's one. Imagine that there is a baseball player and they want to buy a bat. And basically, a rough rule for finding the correct bat length is that it should be half the batter's height. So as it says here, a 62-inch tall batter uses the bat of 31 inches. So write a proportion to find the rest of the bat lengths for each given batter height. So I basically just said that I want to have it 1/2, half, right? And if I know that my example here is 62, if I take this and I figure this out, I divide it by 2, I will get 31. And if I then take this up here and multiply by 31, I will get 31. Do the same thing for 58. So I take 58 on the bottom and I do 60. I can now do the same thing. Now, another interesting rule is called the means and extreme property. I want to show you this. So I didn't know this before. I didn't know that it was 31. I knew it as x. If I take this right here and I cross multiply, so I take 2 times x and I get 2x, and I say that that equals 62 times 1. It's 62. If I want to get x by itself, I have to do that multiplicative inverse or divide by 2, right? So I'm going to do that. And when I do that, I get x equals 31. So that's another way to get here. So let's do the same thing here. I don't know what it should be. I know it's x. I know that this one here has got to be 1/2. So let's do that means of extreme property here. So I'm going to have 2x equals 58. And when I divide by 2 and divide by 2, I know that 25 is 50. So 29 is the answer. X equals 29. And for the 60, I do the same thing where I put down x over 60 equals 1/2. Do that means and extreme property or cross multiplying, and I have 2x equals 60 divided by 2, and x equals 30. And that's the answer. And the last one, of course, is 64. Half of that is 32. So our next one is showing some actual problems here where I have my actual hits. So if I take 20 divided by 80, let me show you this. I go to calculator, and if I do 20 divided by 80, I get this 0.25, which is this 0.25 right here. Over 1,000, I can do this right here. 0.25 is 0.25 over 100. 0.25 would equal 25 over 100. Or the example it has here is 0.250, which is equal to 250 over 1,000. They mean all the same thing, just so we know. So it says here that a batter 50 times at bat and the batting average is 200. So this is how many at bats they have. So I'm going to go through and put that in the bottom. And on top, I have no idea what it is. And when I multiply this, or when I divide this, I'm sorry, I'm going to get 200, or 0.20. So we're going to go through here, and I'm going to do the same thing that I did before, or I'm going to try to solve for this, right? So let's do that now, where I'm going to do my cross multiplying. And if I take 1 times x, I get x equals, and 50 times 0.200, right? Well, let's just do that. So I take 50 times 0.2. I could just leave it at 0.2. It's the same thing as 0.200. I get 10. So let's see if that's accurate. So x equals 10. So if I go through and do 10 divided by 50, I get my 0.2, just like I was looking for. So let's try another one, where it is, I have 84 times that bat. That is my denominator. I don't know what this is. I'll say x, and it all equals 0.250, right? So I'm going to do the same thing, and this is, of course, over 1. And this would be like 1x equals, and then 84 times 0.250. Let's just do that. 84 times 0.250 is 21. And if I take 21 divided by 84, sure enough, I get to 0.25. So this is a really easy way to get these things, okay? Last one here is, or I guess not my last one, but if I have 80 times that bat, and my batting average is 350 over 1, and this is x, of course. So I take my 80 times 0.35, I get 28. So x equals 28. So 28. And if you divide these, you get the 0.35. Now, if I'm at 1 time, and my batting average is 1, well, then let's look at that. So I'm going to go 1 is on the bottom, my x is on top, and 1 is up here, 1 over 1. Well, 1x equals 1. So x equals 1. That means that my 1 time at bat, I also got a hit. So, all right, so the next one says that approximately at a baseball stadium, a stadium holds approximately 45,000 people. So I'm going to write that down. That is my total amount of people, 45,000 people. And it says the ratio of season ticket holders to all tickets is 1 to 3. Well, this 45,000 represents all. So I'm going to go 1 over 3. And I'll put down x over 45,000. I got to figure out what x is equal to. So I can do that means an extreme property we talked about before, where I have 3 times x. So 3x equals 45,000. And when I divide it, x equals 15,000. And if I put this x up here, let's just see if it works. So 15,000 divided by 45,000. I can reduce this down, right? These would go away. This would become, if I divide by 15s, this would become 1 and 3. So that's why 15,000 is the right answer. This next one is like a real life situation that I've actually taught a student that wanted to be a chef one day. He is a chef at a restaurant. And this is where I kind of hooked him into math, because he asked, when will I ever use math? And I said, well, you use proportional reasoning all the time. And this is one example of it. So if I look here, here's my black bean soup recipe. And it says here that we want to make a new amount. We want to make this for more people. And we're going to change it so that way instead of having black beans, I had a half or 1.5 cups before. Now it will be 6. So if I go from 1.5 to 6, right? What's that scale factor there? Well, I can do this a couple of ways. I could take 6 divided by 1.5, and I get 4. So everything that I have here, I'm going to multiply by 4. So for every one of these things. And it says write a proportion that gives the number of X tomatoes in the new recipe. Well, I had 1 tomato before. So now it will be 4 times that. So I'll say 4x. Or I'll just say 4 tomatoes, I guess, right? So that's what it will be. All right, so then the next one here is I want to solve this one. And it says 3 over 2 equals x over 8. So I'll do 3 over 2 equals x over 8. And of course I'm going to do that means an extreme property. So I'm going to have 24 equals 2x. So x equals 12. So I plug a 12 up here, it'll be equal to each other. Okay, so then this next one is this here. Now, notice that it's now on the bottom, right? Versus the top. Same steps. So I'm going to do 5/8 equals 20 over d. And I'll have 5d equals 160 divided by 5, and d equals 32, is that right? And you can do the rest of these as well. And this is how you set them up. So that really is the lesson, and I hope that you understand that we're using the means and extreme property to solve or make these things proportional